This works, amazing, because it has a mute button that's a physical switch, and I switched it to mute, and it's still working. And that's things that amaze me as a software person. If you would excuse me for just a moment, I think I should probably enable Do Not Disturb mode on this, if there is such a thing. Yes. Okay. Now we shall be undisturbed. Thank you. This was a very humbling introduction, and it doesn't help with all the pressure up on my shoulder. My talk is about ephemeralization. Ephemeralization. In our world, mostly, because I find that more inspiring. I'll then also talk about computers. My name is David Zuelke, because I'm German, haha. Don't mention the war, all the old differences are forgotten. I work for a company called Heroku. We do cloud computing things, so you can deploy fun stuff. I will only talk about this very on the side towards the end in this presentation. I'll be up later for a lightning talk, and I'll do a Brave live demo unless my computer fails me. So you can look forward to this. This is my email address if you would like to send me praise, constructive criticism, or non-constructive criticism in private. If you would like to do so publicly, this is my Twitter account. And for the next 30 minutes or something, I cannot respond and defend myself, so this is your chance. This is the term ephemeralization in our world in the cloud. Comes from a word called ephemeral. Does it bother anyone if I pace? I do this like a tiger in a cage. It's an adjective or a noun if something is ephemeral or an ephemeral, and it means that it is something that only lasts for a finite amount of time, and usually that amount of time is short. And it's maybe replaced with something else, but we will look at that in a moment. Imagine for a second a valley. That's the word for these things. It's a valley. This particular one has a river flowing through it. And maybe this is a valley a couple thousand years ago, right? And you would have people up here and people up there. And it's a very, very loud river, so it's really hard to communicate. They can wave. Maybe this is back in the days when people were really stupid and didn't have language. So let's say they can't communicate properly without hugging or something like this. Could be a different world even. And they would like to make trade. They would like to hug. Maybe it's families who got torn apart. Stupid river. Took 1 million years. And they need to find a solution. Now, and they don't know what we know today. So they need to find a solution. And I'm pretty sure this happened, maybe not with a valley this deep, because that would be a daunting task, but I'm pretty sure somewhere in the world, a long time ago, there was a small valley with a river running through it, very long valley, no way to get around it easily, steep. You can't carry anything across. So they took rocks and they threw them in. And that's a process, and it probably needs leadership and determination and a grand vision of someone. But that person kept doing it, and then the other side joined in, and they filled up this hole in the ground. And all of a sudden, they had a bridge to walk on. They made the first bridge in the world. Let's not assume they used some wood things because they didn't have any trees, okay? So there's no trees, there's just stones. It's a stone world. And the hole was filled, and now they can trade. And now they're having a problem because there's a river, and one side of that bridge is now filling up with water. So eventually everything is on the risk of flooding, and they somehow climb down after all because they suddenly learned how to climb and overcome all the obstacles. And they take out some of the stones, right, to let the water through. But over time, like all the stones from the top slip down and the hole closes again. And one day they figure out what shape the hole must be. And then they have a bridge like this. This is one of the oldest ones. It's thousands of years old, somewhere in Greece. And you see you have this arc shape that's stable. So they made a bridge, and this bridge has two very cool characteristics. It's still a bridge, it still functions, but it is better than the last one. It uses actually less material than the last one. And because we're humans, and we always try to there's not all humans, but many humans are always unsatisfied with the status quo and they want to achieve something greater. So eventually they get better at things. They make really nice and neat looking bridges. Ignore the scaffold, please. There is no other photo of this. This is a nicer arc because it has a standard size. I'm assuming a horse would fit through it, which is convenient, and you don't bang your head if you're sitting on the horse, which is an important feature because you don't build bridges for horses, right? And in this case, there's also no river underneath, obviously. This is a very cool bridge. It's more stable. It's a lot neater. It's probably more durable. And then we very quickly and ever more quickly become better at this. So we build another bridge that uses probably the minimum amount of stone for such a thing. Take some more stones away and it'll collapse. But you can scale that up. And that's one important aspect of ephemeralization, that you take material away. You try to do it with less material. But there is ultimately a limit to what you can achieve. For instance, we used to use our hands to measure distances, or we walked. That was inconvenient. If you want to measure something on a wall, well, you can use your hand or your elbow. Then you invent a ruler. For a really long wall, you can use a long string. But eventually, that string won't be straight anymore. If it's too long, it'll sag in the middle, right? And then we probably used, I don't know, an optical way of doing it with a laser, and that has the problem that we can't go around the curvature of the Earth. So we used radar and millimeter waves and satellites and all sorts of clever things. So we changed the ways we built stuff, right? And in this case, it was iron, which has the nice side effect that it's a much lighter bridge, so you need a lot less of it. But iron also has a finite strength. In particular, its tensile strength isn't that great. But one day, a person said, hey, we have this old thing of making, we added a little bit of carbon, it's just stupid, so let's invent a great process that makes this scalable. And then they built steel bridges, right? And with these steel bridges, you can build much larger things. They look like the stone bridges, but they are a fraction of a weight. Probably 2 or 3 orders of magnitude lighter than a stone bridge of the same size. And then someone said, well, steel has this great tensile strength, let's make cables out of it, right? And now we have these amazing, amazing bridges that are just suspended, and the only thing that's still made of stone or actually concrete are these bases, and you have 2 pillars, and we could potentially keep going at this because we will find better and better materials. And one day, imagine if none of that was there, but you could still get across. Does that sound unrealistic? A little bit, right? Because if there is no cables, if there is no road surface, then how will you get across? How would you do that? Well, it may sound unrealistic, very science fiction actually, but if you just imagine how the moon is tethered to the Earth, there is no steel cable, and still it doesn't float away. So one day, there's going to be the day where we get gravity under control, and then we all have jetpacks. and that'll be a good day. And I'll probably be old and have a broken back, and I can't fly jetpacks, says the doctor, and I do it anyway, and then I crash, and it's going to be a glorious death. So this... glorious deaths, I think, are inspiring. Elon Musk, the Tesla guy? He also runs a company called SpaceX. He goes into space. His goal in life is to die on Mars, and I think that's very badass. Anyway, back to bridges. This story about the bridges and stone and how you take stones out and then you optimize and keep optimizing and keep taking material away was I think, frequently told by a guy called Buckminster Fuller. He's a very smart person. He coined the term, or helped popularize the term, synergy, which I'm sure everyone has used before in their lives. And he also came up with the word ephemeralization. He wrote a lot of smart books. He was an architect, a designer. He would always try and build things himself. He built funny-looking, shaped houses, tried to think about the future of our world. This is what he looks like. And he was old by that. He didn't always look like this. But in the end, he looked like this. He would have been 115 this year or something. And he looked at Henry Ford's assembly line, because back then he was alive and already an adult, so he had his own thoughts and not just, I want cheese. So he looked at the assembly line and said, we get more and more productive, like this makes cars being built much and much faster and with less material. And he claimed, or he postulated, that there is no theoretical upper limit, or no apparent upper limit to these increases in productivity. And if you think about, like, we would have to, hundreds of years ago, we would have to walk, and at some point we figured out, hey, these horses are amazing. And then we built horse carriages, and then someone built a locomotive, so we had trains, and people said, oh, like your brain's going to explode when you go 30 miles an hour. And then we built cars, and if you think about cars in particular, and airplanes and rockets, we make them ever, ever lighter, but they go ever, ever further, and they can carry ever, ever more, right? It's accelerating. It's like an upwards curve of what we can achieve with a thing. Because not only we learn to take away, we also figure out new materials and new clever ways, right? And all these things add up to acceleration because we build on our knowledge. Anyway, he said, we could do, it's not what he said, but it's essentially what he said. That's the essence of it. We could do more and more with less and less until eventually we can do everything with nothing. Like float across an ocean with our gravitationally thin cars, right? Like the moon. That was his idea. And we now have to think about, well, can we really achieve everything with nothing? That's just what it looks like, I guess, right? Yeah, who has been to the cinema lately? What? That's 5 people. Crazy. This is funny because we'll get to this. The cinema is, in today's, back then it was amazing. You go to a place, they feed you popcorn, and there's stuff on screen. Like, and sound later on sound. Initially you had an orchestra and they play shitty music. But eventually you would hear people speak and dance on the screen, and that was really, really great. And you could get news from all over the world, and for the first time you see what Japan looks like or some other country. And the inconvenient thing about a cinema is that you go when they show the film, right? And then you have to sit through it. If you drink too much beer, you have to go to the bathroom. If you have to go to the bathroom, you miss the most important scene, where the Arnold shoots the villain with his machine guns. And that's sad. Then you wasted like 10 pounds on nothing, right? So some people said, there must be a way to make this smaller and greater. Hands up, who ever used one of these? Okay, I'm not that old. That's good. That's a VHS. A VHS is a great thing because it enables two amazing things. First, you don't have to leave your house except to pick it up. And second, you can actually pause it. You can also wind it back and forth, and you never find the right spot, and then you're like, ugh. And it's a blurry picture, and it's really shitty technology, and we all know why it won against Betamax. But it's such a big progress because you needed a whole building back in the days, and now you sit in your living room, and you have this really bulky thing that's very noisy and breaks all the time. And my dad couldn't use it. He couldn't even set the clock. He would always take up the manual after a power outage and like, ugh. Anyway, that was big progress, right? And the next step in this evolution was the DVD, obviously, which has great features. You can jump right to a chapter. You can do slow motion things and speed up, and the picture isn't so bad. And then, with the advent of the Blu-ray, something amazing happened. The Blu-ray, one of the reasons why the Blu-ray was successful very quickly is because all of a sudden people, this is a PlayStation 4, but people had all the PS3s at home that would already play Blu-rays. So now you don't even have a playback device anymore. You have a device that already does one thing, and now all of a sudden it can do an amazing other thing, play your movies. And today, your smart TV has Netflix built in. And now you don't need anything anymore. You still need a screen. Eventually, it's going to be a thing that beams pictures into your brain. But for now, let's assume that this is going to be like, I mean the way the film is transported onto your retina, okay? And through a screen. Let's say the screen is not part of the equation. We just went from a cinema with one film a week and a lot of rain outside, and you don't like the popcorn, and the beer is out, to your fridge, your home, your sofa, no devices, all the films in the world. And that's the most amazing thing. You went from everything to nothing in terms of the effort you need and the space you need, and you could do everything now. You can watch every film on Earth if you combine all the streaming services. And live in the right country because rights, blah, blah, blah. Okay. Now, you're going to say, someone might say, pretty sure, like there's many of these thoughts in these brains out there because you're all smart. Yeah, you're welcome. Netflix doesn't run on nothing, you would say, and you're right to insist, because what we have just done is we have made the visible parts smaller, right? We have shifted all this everythingness to someplace else. But that's fine, we'll look at that in a moment. But Netflix indeed doesn't run on nothing, it runs in the cloud. I've made this as big as possible. It gets a lot blurrier afterwards. And the cloud is also not nothing. It's probably a data center like this. And it also runs on another data center that looks very similar, except it's like in a mirror universe on the other end of the world. This is actually CERN's data center, I think, in Switzerland. But these data centers have an interesting capability or an interesting property to them as well. They run the parts that power Netflix, right? Netflix runs on infrastructure as a service. But the cool thing is you don't need a supercomputer anymore. Because natural evolution is, we have a company computer. Like that's what the 60s was, right? Like you would buy this huge thing and you go broke. And then you need someone to feed it. And then there's a bug, like a literal and actual bug, because someone left the window open and the lights on and it goes into the tubes and then the whole thing goes out. And supercomputers used to be these specialized, complicated things, right? Like a Cray or something with special processors, all vector stuff, and they are like specifically designed for one case with specific components. A modern supercomputer, this is the IBM Blue Gene LP something, that's just a big lump of computers, right? And there is no reason why you couldn't have 10 of these somewhere and run the infrastructure on top of that. So it's basically turtles all the way down, right? Like you have components that use components that use components. And the trend is all going more and more in that direction. But on infrastructure as a service, such as Netflix's, because they run on Amazon AWS, the components are still visible. They still have EC2 instances, and they still manage their routers, and they still have the chaos monkey that occasionally kills any of the services running with absolutely no regard for whether or not it's important, just to make sure that this thing never collapses. The engineers are always alert. That's a great thing, by the way. Use the chaos monkey if you have to or can. It'll just kill things. And that's cool because that's one of the aspects why you go to the cloud. You don't have to have your own data center anymore or the service in your company offices. You buy infrastructure, and now it's your responsibility to design it in such a way that it works on that, right? You have the responsibility to make sure that the system you built on top of this infrastructure is still resilient to failure. That if one component fails, there is redundancy for it. The high availability for you is on the physical hardware level. That's provided by Amazon. But on the logical level, like, how do I do failover? You still need to deal with this, right? Like, I need to have a primary and a slave database, etc. So the next step, if you take that one step further, would then be platforms as a service, which obviously I believe in because I work for a platform as a service company. But so that's the next step. You go from supercomputers in your offices to regular computers in your offices to a bunch of regular computers in your offices to a bunch of computers in a data center to a bunch of computers that you rent in a data center to a bunch of computers that you don't see anymore in some data center to a bunch of computing capacity that runs on a bunch of computers you don't see anymore in a data center you don't see anymore. Right? The parts become smaller. And that is what ephemeralization is about. You want minimally visible components that are still individually very strong because they're very simple, right? Instead of having a big thing, you try to build the big thing out of smaller things, and you don't have to have the responsibility for each of them. That doesn't mean you can be ignorant. Of course, the cloud doesn't magically solve your problems, even though a lot of people tend to think so. But this is in general a trend the whole world is moving into, right? And always has been. Look at car manufacturers. They don't build anything themselves anymore. They don't even engineer anything themselves anymore. They just go to a bunch of suppliers, say, ship me that part in that color on that date, and please fix this engine, and this gearbox is not up to our spec, so please change it. And then they build a car, and they put their label on, and then it's hopefully amazing to drive. And the terminology that Bucky, as his friends called him, used for that. I was not his friend, but I think I would have liked to, well, what else? I think he was a cool guy. Called it the kit of parts. You assemble something greater from smaller pieces. And eventually you will have the technology to make the pieces into pieces, right? And one of the things that enables is you can iterate at different speeds for these individual components, and that creates a lot of wealth as well. The people who traded across that bridge initially, all of a sudden they were rich because they could exchange knowledge, food, whatever they built, people, I don't know, everything, right? That creates a lot of wealth. All of a sudden, if you have components that are simple enough, so you can maybe build your own house. Why are we still building houses like we did hundreds of years ago, but your computer you can now set up yourself? Your car you can almost now assemble yourself. There's a couple of companies, I think one's called Local Motors, that ships you the parts. Actually a lot of companies do this to get around regulations. But Because like a bag of parts doesn't have luxury tax because it's not a car. It's a bag of car parts. And then you put it together, right? Some countries do this. And that is, that creates wealth, and that's why he liked this. So he always had this vision of a better society, and he figured out, he had this thing where he said, well, what if we had a world of abundance? He was a firm believer that you could make every person on Earth happy, give them really high quality housing, feed them all. He designed houses made out of aluminium that you could pull up literally on strings, and it would be an amazing thing with sewage and electricity and all of that in it. He was a firm believer in light metals, and he researched aluminium and so forth. And he said, if we have a world where people can just assemble what they need from smaller things, that would be amazing. And that's what we also do in computing, right? We at some point came up with this notion that we should not run our own infrastructure anymore, because 90% of the time it's just idle. So let's outsource that to someone who's smarter than us, which is Amazon. They're very smart. And they now run our infrastructure. And the next step could be, why do I even have to worry about the server? Why don't I just buy computing power somewhere, right? And that's what PaaS is about. And you don't have to manage the components anymore. You can spend your time working on features, for instance, right? And that's exactly what services like Heroku or Engineered or Cloud Foundry do, right? They let you focus on the simple bits. Like in the case of Heroku, this literally looks like you create an app, done. You realize I need a database, done. You have another database. If you prefer MongoDB, you shouldn't. And I'm just kidding. It's so easy. So easy, so satisfying. The dark side. I was watching that the other day, and it's like, the dark side is faster. Anyway, lighter. Redis to go would give you a Redis database, and then you realize, well, maybe I now need messaging, right? Because all of a sudden, your computing power could disappear at any point in time. So if you have stuff that needs to run in the background, enqueue it somewhere and pull it back later. And all these individual add-ons, they worry about the scalability and elasticity as well that they provide you, right? You don't have to manage them anymore. Of course, you have to figure out if you're not doing something wrong in your app, and it's all going to be slow, right? And then you say, well, I would also like to monitor my stuff. So I could use New Relic monitoring, done. And if I want to use GemFury to manage my private repository, I don't have to host a Satis anymore. And the packagist and composer folks are now providing this as well as a service. It's called Toron Proxy, very cool product. Just to plug that, I'm not affiliated with them. Anyway, so that's what you do these days, right? And then you push, and then you're done. That's it. And now you just did a lot more with a lot less. You didn't set up your service anymore. You did not pull an all-nighter because of, what is it, shell thing? Because someone else patched that for you, right? That's the advantage you get when you're on a large supplier. Other people stay up all night to fix that SSL vulnerability for you. And what you saw just is not magic. It may look like magic, but it's just that the parts have become so small that you can't see them any longer, right? You have ephemeralized everything. And now what you have is a portable and a reusable app. And that's something that Fuller was also very, very keen of. He said we should have housing that can move along with us. We should have reusable bits that we assemble. And other architects follow this idea. There was a concept called the plug-in city at some point, where you can literally whole houses, you could put them where you need them at any specific time, right? And then some artists, I think on a lake in Switzerland, did a cloud city once. There was a lot of really small microjets that would just create a huge cloud of water. And you would walk in, and it would sense the people inside, and if the people moved in certain ways, the cloud would move along with them. It would totally encompass them, right? That's very smart. That's not actually livable inside because it's cold and wet, but still. So we have done that with our app. because we don't see the parts anymore. And at the same time, the people under us are doing the same thing. They're also making the parts smaller, right? The infrastructure is now literally in containers. IBM does this for their private cloud thingies. They have these containers. When a Google server fails, they don't use specialized server hardware anymore. It's just like, it's a bit of wood with some stuff on it. And if a hard drive fails, they don't even go send someone to repair it, because that's more expensive than just remotely switching that machine off forever. And this ever smaller things, constructing something very large, very durable, very feature-rich, and very amazing, was one of Fuller's big dreams. This is, I think, in Montreal for the World Expo. He built this big geodesic dome, as he called them. And he loved them. He was very in love with them. He made houses that looked like that, and he lived inside one of those. Turns out they have design flaws. So his is now in not very good shape and is getting restored and refurbished right now. But the fundamental principle is that you have like this structure. He was obsessed with structures that are extremely durable, but they use the minimum amount of parts. And all those parts are made by someone else, right? At Disney World, they built another sphere in his honor. This is in Florida. That's called Spaceship Earth. And Spaceship Earth is a term he also used in one of his books. He actually wrote a book called An Operating Manual to Spaceship Earth. There is one outstanding important fact about Spaceship Earth, he said, is that it has no instruction manual that came with it. That just as a closing thought, because this would be the end. I thank you kindly for listening. I hope this was inspiring. And go to this and rate my talk. And also give a lightning talk in 10 minutes or something, where there's going to be a different QR code, and then you get a free t-shirt when you follow it. Thank you.